All right, this video is covering the 12 questions I gave you with the notes, the sample questions, 6 on 45, 45, 90, and 6 on 30, 60, 90. Of course, these are the 45, 45, 90 right triangles. You can see we have 45 here, which means this is 45, and that's 90. And of course, if these two angles are congruent, it means they are base angles of an isosceles triangle. So we have an isosceles right triangle here. Well, since it's an isosceles triangle, we know if A is 5, then B is 5. And we know that C is 5 root 2. Now we prove this using Pythagorean theorem. If I take C squared equals A squared plus B squared, and I plug in 5 for A and 5 for B, what we end up with is C squared equals 25 plus 25, or C squared equals 50. So now what I would do is take the square root of both sides, because the square root of C squared is simply C, and the square root of 50 is 5 root 2. And that's what we got. So we know, when we know the leg length, remember the legs are the two sides that create the right angle in a right triangle. If we know the leg length of a 45, 45, 90 right triangle, we simply multiply by square root 2 to find the hypotenuse. So here we know B, but remember A and B are interchangeable because this is an isosceles triangle. So if B is 7, A is 7 as well, and we simply take the leg length and multiply it by square root 2 to find the hypotenuse. All right, now if we take the leg length and we multiply by square root 2 to find the hypotenuse, if we know the hypotenuse, we simply divide by square root 2 to find the leg length. So we'll take 3 root 2 and we'll divide it by root 2. And they simply cancel and we get B equals 3, which means A equals 3. Pretty simple. Going on to number 4, we know the hypotenuse is 5 root 2. So if we want the leg length, we simply take 5 root 2 and divide by the square root of 2. These cancel and we end up with A equal to 5 and B equal to 5. Now, of course, it's not always going to be as simple as just dividing by the square root of 2 and canceling out. Sometimes the hypotenuse will not be equal to something times the square root of 2, like in this case. But we still do the same thing. If we want to know the leg length when the hypotenuse is 3, remember, to find the leg length, we simply take the hypotenuse and divide it by the square root of 2. So in this case, we'll take 3 and divide it by the square root of 2. And that would be our answer. That is what A and B equal, but we don't like to leave a square root in the denominator. It's an irrational number, and we don't like to leave irrationals in the denominator. And the easiest way to fix that is to multiply top and bottom by the square root of 2. Why square root of 2 over square root of 2? Because when you divide something by itself, it really equals 1. So what we're doing here is we're multiplying 3 root 3 divided by square root 2 times 1. And when you multiply something times 1, you don't change its value. But by multiplying it by this one, we're going to make it look different without changing its value. So 3 times square root 2 is simply 3 root 2. Square root 2 times square root 2, when you multiply two identical radicals, you get what's underneath. And there's our answer. So 3 root 2 over 2. Seems a little more complicated, but really it's not that much more difficult once you get good at rationalizing denominators. Okay, and the last one, we know that C is 4, so we'll take 4 and divide it by the square root of 2 in order to find A and B. When we rationalize the denominator, we get 4 root 2 over 2, and then we can reduce. 2 goes into 4 twice, and 2 goes into 2 once. So our answer is 2 root 2 for both A and B. And those are every type of question you pretty much will see with 45, 45, 90 right triangles. Okay, going on to 30, 60, 90 right triangles. It's a very similar situation. A little more complicated, but not anything you can't handle. All right, in a 30, 60, 90 right triangle, obviously the small angle is 30 degrees, the larger angle is 60, and then we have the right angle. You need to remember that the shortest side is always across from the 30-degree angle, and I always like to label the shortest side A, just my preference. And then we have the 60-degree angle, which is across from B, the larger leg. The shortest leg is always across from 30-degree angle. The longer leg is always across from 60-degree angle. And of course, the longest side is the hypotenuse C. Okay. Our key here is we always want to find A as quickly as possible because A is really how we find B and C. So when we know A, it's pretty simple. C is just 2 times A. So C equals 2 times 3 in this case, which means it equals 6. So that's pretty easy. If you know A, C is really simple. You just multiply it by 2. Multiply A by 2 to find C. Simple enough. B is actually pretty easy as well because if you know A, to find B, you simply multiply A times the square root of 3. So in this case, B is 3 root 3. Pretty simple. All right, so when we know A, we multiply A by 2 to find C, and we multiply A by square root 3 to find B. All right, simple enough. So using this, we have to work with 2 other situations. One is when we know C. So you'll remember when we knew A, we multiplied by 2 to find C. So when we know C, we should divide by 2 to find A, which means A equals 5 in this case, because 5 times 2 is 10. 10 divided by 2 is 5. Pretty simple. And once we know A, B is pretty easy as well. It's simply A times square root 3 or 5 square root 3. Simple enough. All right. Now, remember, when we had A, to find B, we multiplied by the square root of 3. So when we know B and we want to find A, we're going to do the opposite. We're going to divide by the square root of B. Excuse me, I'm sorry, the square root of 3. And in this situation, it's pretty easy because 7 root 3 divided by root 3, we just cancel those out and we end up with A equals 7. And of course, then we can simply find C by multiplying 7 times 2. Not too bad. One more time, just for practice. When we know B and we want A, we simply divide B by the square root of 3. So in this case, we take 4 root 3 divided by root 3. They cancel each other out, and we get A equals 4, which means C equals 8. Pretty straightforward. Now that's easy when B is something times the square root of 3, but of course that's not always going to be the case, like in example number 5. So in this case, we know B and we want A. So as I've stated, A is equal to B divided by the square root of 3. So what that means in this situation is we have 9 divided by the square root of 3, and that is what A equals. Except for, as we've talked about many times, we don't like to leave an irrational number in the denominator. So we're going to multiply top and bottom by the square root of 3. Again, this is called rationalizing the denominator. All right, 9 times the square root of 3 is just 9 root 3. Something you've really got to get a handle on. The square root of 3 times the square root of 3 equals 3. Anytime we multiply 2 identical radicals, we just get what's underneath. Why? Because the square root of 3 times the square root of 3 is the square root of 9. And of course, the square root of 9 is 3. Whenever we multiply 2 radicals, we just put them under the same roof. Okay, now again, this is what A equals, except we can go one step further. We can reduce. 3 goes into 3 once, 3 goes into 9 3 times, and we end up with simply 3 square root 3. And if we take A to find C, remember we just multiply it by 2. So C is equal to 2 times 3 root 3, which means C in this case equals 6 root 3. All right, so let's go through it a little simpler here, a little quicker without so much steps. So if B equals 5, then A equals 5 divided by the square root of 3. Multiply top and bottom by the square root of 3, and we get 5 root 3 over 3. That is what A equals. Now, C equals 2 times 5 root 3 over 3, which means C equals 10 root 3 over 3. All right, I hope these examples help.